Hello, my Form 3s. How is everyone doing? I hope everyone is doing well. Hey, welcome back to our weekly class for July, first week. Okay, so today we are going to continue on our chapter regarding energy. Okay, so last week we learned about tenaga, energy. We learned about kerja, work done. Okay, we learned about kuasa, power. Okay, I will still remember. If you don't, kindly refer to my video previously. Okay, and one more thing, for this video, it will be combined with two languages, which is English and Bahasa. Okay, so for all the keywords, I will put it in Bahasa. Okay, so hope you don't mind. Okay, because why do I do this? Because the things are mainly similar. Okay, mostly calculations again. Okay, very simple subchapter. Okay, let's get into it. Okay, today we are going to learn about potential energy and kinetic energy, tenaga keupayaan dan tenaga kinetik. Okay, what's the meaning of potential keupayaan? Okay, so when I say you have potential, Anda mempunyai keupayaan means that you can do something. Okay, wow, this kid has a lot of potential. Wah, dia ada bakat, ada keupayaan. Okay, means they are willing, they can achieve something. Okay, but in terms of science, it's almost the same meaning. I can do something. I'm charging my energy. Okay, I have energy yang disimpan di dalam saya. Okay, so if I'm storing energy, I simpan energy, I haven't released the energy, that is tenaga keupayaan, potential energy. I have potential, I have keupayaan to do something. Okay, and then for kinetic energy, we'll learn about this later. Kinetic is to do with speed. Okay, kelajuan. When I'm moving, I have kinetic energy. Okay, so janji benda bergerak, okay, I have tenaga kinetic. Okay, so let's learn about potential energy here. Okay, then it's not mentioned here, but potential energy. Okay, you know what? Let's draw it here. Okay, potential energy, tenaga keupayaan has two. Okay, you are learning two, which is gravitational. Okay, gravitational, in BM is gravity. Okay, and the second one is elastic. Okay, elastic. Okay, so we have two forms of storing energy. One is due to gravity, one is due to elastic, kenyal. Okay, I'm pulling a rubber band. When I'm pulling a rubber band, I'm storing energy in the rubber band. Okay, when I release the rubber band will move, will do something. Okay, keupayaan. Okay, same goes to gravity. When I climb 18th floor up, okay, when I jump down, okay, it releases energy. Okay, when I climb up, I store energy in myself. Okay, so simpan tenaga. Okay, when I climb up, I simpan tenaga. So when I jump, I keluarkan tenaga. Okay, so two forms here. One is gravity, one is elastic. Okay, so let's look at the gravity first. Okay, gravitational potential energy or tenaga keupayaan gravity. Okay, for simplicity's sake, let's keep it simple. I just like to call it GPE. Okay, or in BM is TKG. Okay, because gravitational potential energy, tenaga keupayaan gravity. So let's keep it simple, GPE or TKG. Okay, please don't write this in exam. You should not do this. Please don't write any short forms in exam. Okay, so this is just a lazy way of us studying. Okay, who doesn't like lazy way? Come on. Okay, so definition. Okay, definisi. Okay, gravitational potential energy is the work done to lift an object to a height. Okay, kerja dilakukan mengangkat sebuah objek ke suatu ketinggian. Okay, so imagine this is the ground. Okay, this is the ground. I put an object here. Okay, sorry. I put an object here. This has no potential energy. Okay, because there's no energy tersimpan in this object. But when I bring it higher, okay, now it has energy simpan inside already. Okay, it's storing energy. Because when I release, this thing is gonna fall. Okay, it will do something when the thing is released. Okay, so gravitational energy is due to one factor, which is height, ketinggian. Okay, so the higher you climb, okay, let's say now you climb from you climb to 18th floor. Okay, you climb to 18th floor, I climb to 5th floor. For me, very easy. Okay, 5 floors only what? Okay, I naik 5 tingkat itu saja. Okay, I just climb like 5 flights of stairs. but you have to climb 18 flights of stairs. You are using more energy, I'm using less energy. That's why I'm storing less energy. I use less energy, I store less energy. You use more energy, you store more energy. Okay, I have less tenaga. Okay, I menggunakan tenaga yang lebih rendah. I also simpan tenaga yang lebih rendah. Okay, and then you are lebih and lebih. Okay, so like I said, energy is very fair. How much energy you give it, how many you will store. Okay, so height. Okay, so the formula here is given by mgh. This is what you should memorize. Okay, mgh. Okay, what does it mean? M stands for mass, okay, which is gsim. Okay, I rewrote it for you. Okay, gsim. Okay, so in your notes you shouldn't have this bm1. Okay, if you're using a bm note, then good for you. Okay, if you want to write it down, okay, you can pause this video and write it down. Okay, so M is gsim. Okay, mass. Okay, and then G. Okay, what is G? G is something what we call gravitational acceleration, pecutan gravity. Okay, what the hell is this thing? Okay, pecutan gravity is different from every planet. Okay, different for every planet. Okay, like I'm sure you know, on the moon the gravity is less, but in Earth is slightly higher. Not slightly, exactly, a few times higher. Okay, so for Earth, our pecutan gravity is 10. Okay, 10. Is this thing fixed? Yes, it is. Okay, you just have to remember this. But don't worry, in exam, normally they will put at the end of the soalan, they will put G sama dengan 10. They will tell you, okay, in case you forget. Okay, so G is fixed everywhere. Unless you go moon, then different story. Okay, you go matahari, I don't think you can go matahari lah. You be burned to whatever. Okay, so I don't think you need to learn others. Okay, 10 is the fixed one. Okay, so H is ketinggian lah, height. Okay, so mgh, which means mass gsim times G times height. Okay, mgh. Okay, so the unit is joule, because last week we learned energy is joule. Okay, so same thing here. This is tenaga, this is kerja. Okay, work done is kerja lah. Okay, kerja is the same as tenaga. Okay, tenaga is keupayaan melakukan kerja, the ability to do work. Okay, so same thing. Okay, so same thing here. Okay, so this working, how do we get this mgh from? You don't need to know. Okay, tak kisah. Okay, tak kisah. If you want to know, okay, you can read it yourself. It's not gonna be asked. Okay, you don't even have a PhD right now. Okay, so who cares? Okay, but you know what? It feels good to learn something new. Okay, so if you would like to get to the bottom of this, okay, you may go ahead. Okay, so anyway, let's look at question 8. Okay, calculate the potential energy of the box. Okay, by potential energy, I think is the gravitational lah. Okay, it's not mentioned here. Okay, gravity, keupayaan gravity. Okay, so we use mgh. Okay, very simple. So it's my m here. M is my 3. Okay, you see they give you G. G sama dengan 10. Always they will give. If they don't give, please raise up your hand and ask your teacher. Okay, you don't need to lah. Okay, it's 10. Okay, so times 10. Okay, what is the height? Ketinggian is 2 meter. Okay, so 3 times 10 times 2, you get 60 joule. Okay, so now I am giving the box, I use 60 joule from my muscle to lift this box up. Now this box has 60. You get what I'm trying to say? Okay, I'm giving energy, and then this box receives the energy. Energy will not just be gone like that. Okay, like the sejat will evaporate from thin air. No, energy cannot be destroyed. Energy can only be converted to somewhere else. So now I'm giving 60 joule. Now the box got 60 joule. You might say, then sir, how do we get the 60 joule? You get it from food. Okay, you eat to fuel your muscles. Okay, so where do your food get energy from? The energy get it from, let's say you eat chicken. Chicken get energy from plant. So where plant get energy from? Plant get energy from sun. That's biology already. Okay, so can you see energy will keep flowing. So from sun, which is light energy, so change it to chemical energy, tenaga kimia. So the chicken eat the tenaga kimia, the chicken also become tenaga kimia, and then you eat the chicken, it's also tenaga kimia, and then you move this thing become tenaga keupayaan gravity, gravitational potential energy. You see? Energy is being converted here, 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 and here. Okay, so very fascinating. Okay, so let's look at B. Calculate the potential energy. Okay, again, this is the GPE. So mgh again. So what's my M? M for this guy, okay, for this athlete is 50, 50. Okay, you see they didn't give the G here. Okay, G is 10. Always 10 unless you jump this on another planet. Different story. Okay, so what is H? H is this 5 meter. Okay, so you should get 2500 joule. Okay, quick math. Okay, so you should use the calculator. Okay, so C, Ifat and Sam each have a mass of 40 and 55 respectively. They climb stairs with height of 2 meter. Who has more gravitational potential energy? Okay, by looking at this, you know Sam is using more energy because Sam is heavier. Okay, but let's show them. Okay, so this is Ifat, this is Sam. Okay, so mgh here. So m is 40 for Ifat, g is 10 always. Okay, h is 2. Okay, so I get 800 here. Is it 800? Yeah, I think so. 800 joule. And then for Sam, mgh, okay, 55 times 10 times 2. Okay, so I get 1001 here. Okay, so for fat people, you're actually using more energy to do something. Of course, okay, it's like a lorry uses more fuel, more petrol than a car. Okay, a lorry is harder to move because it's so heavy. Okay, 4 times heavier than a car. Common sense lah kan. Okay, so D, an object placed at the height of 8 meter. Okay, so if you say you're confused, you just put a H here. Okay, from the surface. Okay, and now you see they give you energy. They give you Tenaga. So how? Okay, it's the Songsang lah, reverse lah. Okay, so we know that GPE, okay, or TKG sama dengan MGH. Okay, so now they give you this. They give you the TKG. So 2000 sama dengan MGH. Okay, so they want to calculate the mass. Okay, so M we don't know. G is always 10. Okay, and then H is 8. Okay, so what do you do? M equals to 2000 bagi 10 bagi 8. Okay, you move this thing down. Okay, maths lah. I'm not going to tell you how do I do this. Okay, this is 8, sorry, not 80. Okay, so 200 divided by 8 should get 25 kg. Yes, okay, 25. Okay, use a calculator. I'm just doing it quickly. Okay, so next, question E. This is a bit longer. Okay, a leaf, leaf lah, can carry a load of mass of 1005. Okay, you know your leaf. Okay, you go into your leaf. Normally on the leaf, they have a muatan berat there. Okay, if it's 1005, if it's over, then the thing will beep, the thing will not move. Okay, so 1005 to a height of 30. Okay, how much work is done? Berapa kerja dilakukan? Okay, so kerja is the same as GPE lah. Basically, they're asking for the GPE. Okay, so just write GPE or TKG, tenaga keupayaan gravity, sama dengan MGH. Okay, so M is 1005. Okay, G is always 10. It's not mentioned here, but doesn't matter. H is 30. Okay, wow, this is a big number. So 15,000. Okay, you should get 450,000. Yeah, okay, joule. Wow, big number. Okay, that's why you see a lift uses a lot of electric to move. Okay, that's why, because it moves so many people. 1005, imagine each person averagely is like 70 kilo. You can move 20 something people inside there. Okay, so this is a pretty big lift. Okay, so what is the GPE? Okay, so we already calculate this. So basically this is the answer for A and B. Okay, so C. Okay, C. What is the relationship? Okay, hubungan. Okay, sorry, forgot to write this. Okay, hubungan antara, okay, work done, kerja, okay, and the GPE of the lift. So, okay, what's the hubungan antara kerja dan tenaga keupayaan gravity? What's the relationship between work done and gravitational potential energy? Okay, so the answer is GPE, okay, is the work done, okay, to move an object to a certain height. Okay, so GPE is work done. Okay, so tenaga keupayaan gravity ialah kerja dilakukan untuk mengangkut suatu objek ke suatu ketinggian. Okay, so tenaga keupayaan gravity adalah ialah kerja. Okay, that's the relationship. Okay, so D, what is the power if the time is 0.5 minute? Okay, 0.5 minute is 30 saat lah. Okay, 30 second. Okay, so basically what is power? Power is kerja or work done divided by time lah, masa. Okay, so we already got our time here, our work done here. Okay, so we straight away take, power is equal to 450,000 divided by 30 second. Okay, 30 saat. So what do you get? Cut here, divide by 3, you should get 15,000. Okay, watt. They don't want in watt, they want it in kilowatt. So what do? Divide by 1000 lah. So this is sama dengan 15 kilowatt. Okay, normally we use kilowatt lah. Even the meter outside your house, the one that calculates your bill electric, the one uses kilowatt also. Okay, because it's easier. So many zero in your bill that it's very hard to see. Okay, so next, let's look at elastic potential energy. Okay, that is your tenaga keupayaan elastic. Okay, just now it's because of gravity. Okay, gravity. Now it's because of elastic. Okay, kenyal. When I pull a rubber band or when I press a spring. Okay, so different situation. Just now it's due to height. Now it's due to condition. Okay, so what is elastic potential energy? Is the work done to compress or stretch an elastic material. Okay, so tenaga keupayaan elastic, okay, or let's put it short form lah, EPE. Just now TKG mah, so TKE. Okay, so TKE adalah kerja dilakukan untuk memampat atau menegangkan suatu objek kenyal atau elastik. Okay, mampat is I press. Okay, mampat. Okay, menegang is I pull, tarik. Okay, so mampat atau tegang. Okay, so you have another formula here. Just now it's mgh. Okay, now it's this. Okay, 1/2 fx. Okay, so I'll highlight this for you. Very important. So what is F? F is daya. Okay, how much force I'm using. So X is the displacement from the equilibrium. Sesaran dari kedudukan seimbang. Okay, what does it mean? Okay, let's say now I have a rubber band. Okay, this rubber band is 10 cm. Okay, so now I pull it to 50 cm. Okay, so how much longer did it get? Okay, it got longer by 40 cm. So the 40 cm is the X lah. Okay, means you can also say perubahan dalam panjang. Okay, change in length. Can, no problem. Okay, so you have a graph here. Basically, you are calculating the area under the graph. Okay, but again, this is Form 4 stuff. Okay, yes, if you are very interested in pure science, next year, if you are going into physics, you will see a lot of this. Okay, so if you are interested in getting into pure science, I suggest you master this part because it's almost exactly the same. Okay, so unit, same thing, Joe, because this is kerja as well. Okay, just now it's due to gravity, now it's due to elastic, but it's kerja. Okay, you use the makanan, the food you eat to change your energy to pull the rubber band. Same thing lah. Okay, you pull 60 Joule. Okay, just now I lift the object 60 Joule. Now I pull a rubber band 60 Joule. Same thing, I'm using energy from my muscle to store energy inside the rubber band. Okay, concept sama. Okay, so A, calculate the potential energy stored in a compressed spring. Okay, so I use half Fx. Okay, so what is F? F is my daya. Okay, daya I use 5. Okay, I use 5. Okay, 5 times from 50 to 25 cm. Okay, please change it to SI unit first. Don't just really say 25 cm. So my X is 25 cm is equal to 0.25 meter. Okay, change it to meter first because that's a unit SI. Okay, so 2.5 times 0.25. Wow, this is a long answer. I think it's 0.625 joule. Is it? Okay, oh yeah, that's the answer. Okay, yeah, that's the answer. Okay, so don't do it like me, I'm lazy. Okay, so calculate the elastic potential energy of the elongated spring. Okay, so again, half Fx. Okay, so what's my F? F is my 60 lah. Okay, 60. And then my X is 0.2. Why? Because 20 cm. Okay, 20 cm. Change it to meter. Okay, so this is 30 darab 0.2, you should get 6 joule. Okay, so that's why I pull rubber band when I jentik to your skin. You feel pain because the energy is released onto your skin. Of course, you feel pain. Okay, so next, C. A spring with length of 20 cm, okay, let's put 0.2 here, okay, was compressed, okay, dimampat with a 2 kg weight. Okay, 2 kg, you change it to Newton first, which is 20 Newton. Okay, we learned this last week, if you still remember. Okay, till the length decreased to what, 12 cm, which is 0.12. Okay, so what's my X here? My X is 0.2 minus 0.12, so it's 0.08 meter. Okay, so my spring shortens by 8 cm or 0.01 meter. Okay, so what is the value of EPE? Okay, so EPE or TKE sama dengan setengah darab Fx. Okay, so my F is 20. Okay, my X is 0.08. So my answer is 0.8 joule. Okay, easy. Okay, so D, figure below shows an arrow put on an elastic bowstring. Okay, bow is buso lah. Huh? Okay, so this is pana. Okay, so bow and arrow. Okay, so the bow was pulled with 25 Newton force. It was pulled 0.5. Okay, now they give you meter from original line. Okay, so now this is straight away the X already. Okay, so calculate the EPE. So EPE atau TKE sama dengan separuh Fx. Okay, so F is 25, X is 0.5. Okay, so I should get 6.25 joule. Okay, quick math. Okay, so don't do it like me. Use your calculator. Okay, so next E, the original length is 20. Okay, when the force is 20, the new length becomes 12. Are they the same question? Oh, this is the same question. Soalan sama lah tu. Okay, same thing. So don't do this. Same thing. Okay, so next, let's look at Tenaga kinetic. Okay, kinetic energy. Okay, this is much simpler. Okay, kinetic energy is the energy possessed by a moving object. Dimiliki oleh objek bergerak. The key point here is bergerak, moving. As long as I'm moving, I have kinetic. See? Kinetic. As long as moving is kinetic. Okay, a car has kinetic energy. When a car is stopped at the red light, okay, lampu hijau, lampu merah, okay, you henti there, tenaga kinetic is kosong. Okay, kosong. Okay, so the formula is this. Okay, separuh mv square. Okay, mv square, half mv square. Okay, so we have three formula to memorize here. Okay, mgh, half fx, and half mv square. Okay, how do you memorize that? Okay, I'll just do it yourself. Okay, so a train of mass 500,000 kilo, okay, moves with a velocity of 360. Wow, you know what? They should give it in meters square. They shouldn't give it in kilometer hour. Okay, usually they will give it in like this, okay, meter square, because this is the unit SI. This is not unit SI. They shouldn't give it like this. Okay, you know what? Let me convert it real quick. Okay, 360,000 divided by 36. Okay, you should get 1000 meter per second. Okay, so now we really convert to this. Okay, how do you do this? You don't need to know. This is physics punya pasal. Don't care. They should always give you in meter per second. Okay, so this is my m. This is my v. Okay, v is, oh, so sorry, forgot to tell you. V is velocity or hal laju. What does it mean? Velocity means speed lah. Okay, kelajuan. Okay, speed and velocity, kelajuan and hal laju is the same thing. Okay, yes, they are different, but they are the same. I hope I'm making sense here. Okay, for your level, it's the same. Okay, they have a small difference when you're learning in physics, but they're the same thing. Okay, so when you see halaju, kelajuan, same thing. Speed, velocity, same thing. Okay, so I use my KE. Okay, I put it KE here lah, or Tenaga kinetic. Okay, or you're gonna put TK also can. Okay, so this is half mv square. Okay, so my mass GCM is 500,000. Okay, a very heavy train. So this is 1,000 square. Wow, the answer should be pretty damn long. Okay, so many zeros here. 250000, and then I think 6 more zero behind. Joke. Wow, what a stupid question. Okay, so long. Okay, normally you don't see questions like this in exam, don't worry. Okay, a superhero with a mass of 50 kg, okay, flying at constant speed of 800, calculate his KE. Okay, so KE atau TK sama dengan mv square. Okay, so mass, this fellow is only 50 kg, very light. Okay, and then 800 square. Why is the answer so big? Okay, wow, this is hard to calculate. I have to use my calculator. Okay, so 800 times 800. Okay, and then you times 25. Wow, 16 million. Okay, so wow, what a long Joe. Oof. You should not see questions like this. Okay, there's so many zeros. Okay, so a ball bearing. Okay, ball bearing is okay, you need to know. Okay, 0.2 kg possess kinetic energy of 3.6. Now they give you the KE, okay, or the TK. What is the velocity? Now they want the V. So KE or TK sama dengan half mv square. So now they want the V. Okay, so circle the V. So this one is 3.6. Okay, 1/2. GCM is 0.2, and then V square. Okay, so you throw everything there. So 3.6 times 2 is 7.2. 7.2 divided by 0.2 is 36. Yeah, it's 36. Okay, so 36 is same as V square. Okay, so please don't remember the square root. Okay, so throw it there. V equals to square root of 36, which is 6 meter per second. This answer makes more sense. Okay, so not so many zeros here. Okay, so next, let's look at question C. Calculate the KE of an electron. Why is there so many zeros here? Okay, fine, whatever. Okay, do the calculation yourself. Okay, half mv square. You just sub all the value inside. Okay, this is the m. 9 times 10 negative 31. 4 times 10 6 square. You know, I'm not gonna bother. Okay, key into your calculator yourself. Oh my god, why is this so long? Okay, so a flea is kutu. Okay, 0.5 milligrams. Seriously. Okay, milligram is very light, which is 0.5 times 10 negative 3. I hope you learn the index number. Okay, number index. Okay, can jump at the speed of 1. Calculate the KE. So KE atau TK sama dengan 1/2 mv square. Okay, so my m is 0.5 times 10 negative 3. V is 1 square. 1 square is 1 lah. Okay, so this one you should get 0.25 times 10 negative 3 joule. Okay, so that's it for what we are going to learn today. Okay, so you learn 3 things today, which is GPE, TKG, which is gravity, EPE, TKE, which is your elastic, and then your KE or TK. Okay, so let's go into our exercise. Video is getting a bit long, so I'll only talk about a few questions. Identify the type of energy. Jenis tenaga terlibat. So this is your TKE. Sorry, I'll write English first. Okay, which is EPE or TKE. Okay, write the name yourself, the long name yourself. Okay, this fellow is running, so this is KE or TK. Okay, this is due to height ketinggian, so this is GPE or TKG. Okay, many forms of energy match the following. Okay, tenaga keupayaan is what? Okay, tenaga keupayaan is keupayaan melakukan kerja. Okay, yes, I think it's this one. Oh, no, sorry. I think it's this one. Okay, this one, ability to do work, keupayaan melakukan kerja, this is tenaga. Okay, energy. Okay, so for potential energy is this one. Okay, energy possessed by an object due to position or condition. Dimiliki objek disebabkan oleh kedudukan atau kondisi. Okay, so KE is this one, moving object. So E, what is the relationship between GPE and work? Okay, hubungan antara TKG dan kerja. Okay, so I already told you just now. So GPE is the work done. Okay, to move an object to a certain height. Okay, so TKG ialah kerja, okay, dilakukan untuk mengangkut suatu objek, okay, ke satu ketinggian. Okay, so EPE, same thing. So EPE is the work done, okay, to stretch or to compress an object. Okay, so tenaga kinetik, tenaga keupayaan elastik ialah kerja dilakukan, okay, write it yourself lah, untuk mampat atau menegangkan suatu objek. Okay, simple. So two situation. Okay, namakan the tenaga keupayaan. So for A is elastic. Okay, I'll just write EPE or TKE. So for B, this is ketinggian. So GPE or TKG. Okay, B, differentiate between A and B. Bezakan A dan B. Okay, so A is caused by compression, okay, or tension. Okay, compression is press, tension is pull. Okay, so in BM, A disebabkan oleh mampatan, okay, sorry, mampatan atau ketegangan. Okay, mampatan, ketegangan. Okay, so B is caused by change in height. Okay, so B disebabkan oleh perubahan ketinggian. Okay, so C, in situation A, the work done by the boy to stretch the slingshot is 30. Okay, so to pull this thing is 30 lah. State the amount of potential energy possessed in the slingshot. Okay, so if the boy uses 30, so inside here got how many? 30 lah. Okay, so the answer is same, sama. Okay, or you can say 30 joule. Okay, why? Explain why. Okay, because the 30 joule produced by the boy, okay, is converted to EPE and stored in the slingshot. Okay, so for BM, 30 joule dihasilkan oleh budak dan ditukarkan ke TKE dan disimpan di dalam, what do you call slingshot in BM? I've forgotten. Okay, so simpan in that thing lah, you understand? Okay, so calculate the amount of PE stored in the metal ball. Okay, so this is due to height, so obviously this is MGH lah. Okay, so you want to write GPE or TKG sama dengan MGH. So M is 1.5, G is 10 always, H is 75 cm. Don't put this in cm, this is 0.75, which is meter, our SI unit. Okay, so 15 times 75, I think is 11.25 joule. Use your calculator. Okay, so a watermelon of mass 5 kg is placed on top of a table. Okay, now different story, is it? Yes, different story. Okay, so now I have a table, I put 5 kg. Okay, height 0.8. Okay, if G is 10, Okay, what is the GPE? So GPE or TKE sama dengan mgh. M is 5, G is 10, H is 0.8. Okay, so you should get 40 joule. Okay, so C, the watermelon breaks when it falls from the table to concrete floor below. However, if a similar situation occur on the moon, the watermelon will not break. Okay, let me translate this. Okay, sebuah tembikai akan pecah apabila jatuh dari meja, okay, ke lantai konkrit. Okay, okay, apabila berlaku pada bulan, tembikai tidak pecah. Okay, jelaskan mengapa. Okay, this is a very good question. Okay, G on Earth is 10, but for Moon, it's 1/6 of 10. Okay, which is like what? 1.6, 1.67. Okay, so can you see the G in Moon is much lighter? Okay, so what do you say in the first point? Okay, so what is the G stands for? Okay, that is your gravitational acceleration. Okay, on Moon is lower than Earth. Okay, so pecutan gravity pada bulan lebih rendah daripada bumi. Okay, so using the formula mgh, okay, if my G is lower, it is GPE. Okay, if my G is lower, of course my GPE will be lower. Less energy is in the watermelon. Of course, less energy when it falls to the ground, of course it won't break. Okay, so less GPE stored in watermelon. Okay, so TKG yang lebih kurang, okay, disimpan di dalam tembikai. Okay, so what happens? Less GPE, we can say watermelon does not break. Okay, TKG yang lebih rendah, tembikai tidak pecah. Okay, more energy, more damage it will cause. That's why in small accident you don't die. Huge accident, very strong crash, you die because so much energy is on you, you cannot release away the energy. That's why you die. That's why the function of the airbag and the seat belt, okay, the tali geledah and the airbag is to release your energy so that the energy is not on you, so that you don't die. Okay, so that's a science way to explain that thing. Okay, so you can continue to do this yourself. Okay, they are the same concept. You can do questions 14, 15, 16, even 17. Oh, 18 is the same question as well. Yes, you can do until 18. Okay, so next week we will continue with this part. Okay, please understand this part fully because next week we will use back the same thing and explain how GPE changes to KE. Okay, so make sure you understand your GPE and your KE because next week we will use it back again. Okay, so that's it for this week. Okay, I hope you learned something new. Okay, treat this part seriously because if next year you're going to take physics, you are going to see this thing again. Trust me on that. Okay, so that's it for this week. I'll see you again next week. Okay, so if you like this video, give it a like, subscribe to my channel. If you're interested to join my live class, you can go to ttceducation.org or go to Facebook and search TTC Education. See you next week and bye-bye.